Video editing should feel like piloting a spaceship, but somehow it still feels like office work. So I built this. It's not a keyboard, it's not a macropad, and technically it's not even a mouse. It's basically a second hand for editing. I spent hundreds of hours editing videos, and eventually I noticed something weird. Most of editing is just moving through time. Forward, backward, zoom in, zoom out, cut, select, over and over and over again. And somehow we are still doing all of this with tools designed for spreadsheets and emails. That makes no sense. It's true that we have hotkeys and we can choose a keyboard combination for a design action. But when you have a couple of them, it really turns out to a mess. So I started thinking, what if editing felt physical? What if scrubbing through a timeline actually felt like controlling something real? I didn't want another macropad covered in 50 buttons. I wanted one perfect interaction, a dedicated editing station for the other hand. So naturally, I started looking online to see if something like this already existed, and technically it does. There are professional jog wheels and editing controllers out there, but most of them are insanely expensive. And look, I'd love to spend hundreds of dollars on fancy editing gear, but I also have 2 daughters to feed. So instead of buying one, I decided to build my own. Minimal, focused, ergonomic, intuitive, intentional. Every project starts with a sketch, and by a sketch I mean whatever this is. I'm not an industrial designer. This is basically just caveman engineering with extra steps. The goal wasn't to make something beautiful yet. I just needed to figure out where the controls should live and how this thing would actually feel in the hand. It's the first prototype, so I mostly used whatever I already had lying around: a rotary encoder for the jog wheel, a push button, a touch sensor, and an ESP32 microcontroller to control everything. Nothing fancy. This version was never supposed to be perfect, it just needed to prove the idea worked. Version 1 is always a little ugly, that's part of the charm. One of the biggest decisions was figuring out how the device should communicate with the computer. There were basically 2 approaches. The first option was making the microcontroller behave like an HID device, basically pretending to be a keyboard. That means every input from the controller sends actual keyboard shortcuts directly to the editing software. It's simple, it's plug and play, and it works on basically any computer without additional software. The second option was a lot more complex and advanced. Instead of sending keyboard inputs directly, the device could send serial data to custom software running on the PC. That software would interpret the commands and then decide what actions to perform. It's definitely more powerful. You can create modes, dynamic controls, custom behaviors without reflashing the firmware every time. It's also technically safer because the microcontroller isn't pretending to be a keyboard. But there's one problem. It's not plug and play. And for version 1, I wanted this thing to just work and be the simplest as possible. So I decided to go with HID mode. The ESP32 also supports Bluetooth, which means this could eventually become completely wireless. And honestly, that would make the whole setup feel way cleaner and more minimal. Bluetooth latency is always surprisingly usable for this kind of device. But going wireless also means adding a battery inside the enclosure, charging circuitry, power management, a whole new layer of complexity, and physical volume. Remember, I wanted to make it tiny. So for now, I kept it wired through USB-C. Simple, reliable, low latency. Wireless can wait for the version 2. Remember, it's just a prototype. The first problem showed up almost immediately. The knob looked way too small compared to the body. It technically worked, but visually it felt off. So I scaled it up by about 40% and printed it again. Much better. But then another issue appeared. The inside groove of the knob has this curved spherical shape, which means the printer has to deal with a pretty nasty overhang. And because of the support material, the surface came out rough and uneven. Normally, I would sand it down properly, except I didn't have sandpaper, so I improvised, using pliers, I slowly started smoothing the surface out by hand. Not exactly professional, but surprisingly effective. And then the printer started fighting back. Some prints failed halfway through because filament kept clogging inside the extruder. At one point, it basically turned into molten plastic spaghetti. And honestly, 3D printing is basically a machine that teaches you patience through suffering. I also got reminded of the most important rule in 3D printing. If the first layer sucks, everything sucks. And even when the prints actually succeeded, they still didn't fit it correctly. Some tolerances were too tight, some parts were too loose, and in one version I completely forgot the hole for the button, which is kind of important. The hardware worked. Then came the software side of the project. For the controls themselves, I focused on the actions I use the most while editing, scrubbing forward and backward through the timeline, cutting clips, deleting, play and pause, simple actions, but the kind you repeat thousands of times. And weirdly enough, those tiny repetitive actions are what make editing either feel smooth or exhausting. But the controls inside DaVinci Resolve didn't behave the way I wanted. There were basically two ways to fix it. Option 1 was modifying the firmware itself, or I could remap everything directly inside DaVinci Resolve using my custom hotkeys, which honestly turned into this weird battle between software and hardware. And then I ran into one of the most annoying problems of the entire project. Once the firmware was flashed, the microcontroller starts behaving like a keyboard, which sounds cool until you realize your computer no longer recognizes it normally. So every time I wanted to update the firmware, I had to hold down the boot button before plugging the board in. Otherwise, the computer just wouldn't detect it properly. And after forgetting that approximately 50 times, it finally became muscle memory. And then, it finally happened. The first time I edited with it, I immediately understood the difference. It didn't feel like using a shortcut. It felt like touching the timeline directly. And weirdly enough, editing suddenly became fun again. Most editing controllers try to do everything. Dozens of buttons, layers, menus, tiny screens, but I think that misses the point. This device only does a few things, but it does them really well. Less friction, more flow. It's not about adding complexity, it's about removing distance between your hand and your creativity. What started as a random side project slowly became something I now use every single day. And honestly, editing without it feels wrong now. But this is probably just version 1, because I think there's an entirely different future for creative tools, and this might be the first step. But honestly, this is just the beginning. One of the biggest upgrades I want for the next version is modularity. Instead of one single device, I want multiple modules that connect together. The main unit would contain the microcontroller, and the extra modules could attach magnetically, using those magnetic pogo pin connectors. So both power and data transfers automatically without soldering. I could even design a fully 3D printed magnetic connection system, although that gets complicated pretty quickly because of the tolerance and that stuff. I also want the shape to feel way more ergonomic, more natural curves, better hand support, something that feels designed around the human hand, instead of just being a box with buttons. And eventually Bluetooth with an internal battery. Since the device already uses USB-C, adding charging support in the future makes a lot of sense. Right now, changing functionality usually means refreshing the firmware, which works, but gets annoying fast. So I want future versions to support multiple modes directly on the device, switching behaviors instantly without reconnecting or replacing anything. I'm not referring to changing button modes while editing, although that's also possible, but to modes for using the device for purposes other than editing, such as composing and producing music, among others. I also still want to experiment with different communication methods, especially the idea of dedicated software running on the PC. It's definitely more complicated, but I could unlock way more flexibility long term. I also want another button on the opposite side of the device, keeping the minimal design. And I'm thinking about replacing the current click button with either a proper keyboard switch or even a mouse switch, mostly because of the sound and the fingers feeling. The challenge is keeping everything minimal while still making it more versatile. I don't want this to become another complicated control panel. The simplicity is part of the whole point. I also want to improve the internal 3D design, adding proper alignment guides for the sensors and modules, like we have for the microcontroller. So, assembling everything becomes way easier and more precise. Right now, this is still very much a prototype. A functional prototype, but definitely still version 1. I want to design a completely custom PCB. No loose wiring, no messy internals, everything perfectly fitted together. Which also means doing a proper PCB design and creating my own driver files from scratch. So, if you want the STL files, the firmware code, the wiring diagram, or even the next version of this project, just let me know. Because this is really just the prototype. The interesting stuff starts after this. Modularity, wireless, better ergonomics, custom hardware, and honestly, I think this could become something really cool. So, if you want to see the version 2, you know what to do.